Hello, in this video you'll learn about scale and similar figures. First off, a scale drawing is just an enlarged or reduced drawing that's similar to the actual object. So this idea of similar we're going to come back to. The scale is the ratio of the distance in the drawing to the actual distance. This idea of similar means that they're going to form a proportion so that we can use proportional reasoning to solve. So let's see an example. The scale on a map is 1.5 inches to 40 miles. So every 1.5 inches on the map represents 40 miles in real life. If the actual distance between two cities is 60 miles, how far apart would they be on the map? Well, I want to set up a proportion for this. And one way to do this is I can use my scale on one side. 1.5 inches represents 40 miles. Now, we know when we're setting up proportions, it's really important that we're comparing the same thing. So on the left side, I'm comparing inches to miles. So on the right side, I also want to compare inches to miles. Well, I know that the actual distance is 60 miles, so 60 should be in my denominator here, and I want to know how far apart will they be on the map. So that's my variable. And now I just want to solve this proportion here. I can solve this by cross multiplying. 60 times 1.5, that's 90. 40 times y is just 40y. Can divide both sides by 40, and I get y is equal to 2.25, and I want to make sure I use my units, inches. So that's how far apart they would be on the map. All right, here's one for you to try on your own. The two cities are 7 inches apart on a map, and the scale on the map is 3 inches to 250 miles. So every 3 inches on the map represents 250 miles in real life. We want to know the actual distance between these two cities. So we want to know the miles. This is what we don't know. This is our variable. What we do know is we know on the map they're 7 inches apart. So I'm going to solve this proportion. I can solve it by cross multiplying. 3 times x is just 3x. And 7 times 250, that is 1,750. To solve this for x, I'm going to divide both sides by 3. And I'm going to find out that x is equal to 58.33 miles. All right, now let's look at similar figures. Similar figures are figures with corresponding angles that have equal measurements, and the corresponding sides have proportional lengths. And this symbol here means that the two are similar to each other. So I know these two trapezoids are similar to each other. I'm telling you that they are. And that means that this angle here and this angle here, they both measure 120 degrees. And then these angles down below, because this is a similar figure, they both measure 60 degrees. And so now I want to figure out what is angle S equal to. I'm going to write a proportion, and here's how I think about writing my proportion. I think about the top side of the figure on the left, which is 6 centimeters. So I'm going to compare the top to the left side. So 6 centimeters to 4.5 centimeters. And that's going to be equal to, and now when I compare using the other figure, I want to again make sure I compare the top of it, 4 centimeters, to the left, S. So 6 times S, that's just 6S. 4 times 4.5, that's equal to 18. Divide both sides by 6 to isolate the variable, and I find out that S is equal to 3 centimeters. But did you know you could also have written the proportion differently? I could have compared the top of the big one to the top of the smaller one. So that would be 6 centimeters was the top of the bigger trapezoid, compare that to 4 centimeters. And then the other side of my proportion, I would compare the left side of the bigger one, 4.5, to the left side of the smaller one, which is S. Notice that when you cross multiply, you're going to cross multiply the same thing. 4 times 4.5 and 6 times S. You'll still end up at the same answer. All right, let's take a look at this next example here. This is going to use what's called indirect measurement. So a 6-foot tall person casts a 7-foot shadow. She stands next to a building that casts a 50-foot shadow. How tall is the building? So let's draw this out. Here's my building. I don't know how tall it is. That's going to be my variable. I know it casts a shadow that's 50 feet long. Well, this looks to me like it's in the shape of a triangle. Now, what else do I know? I know there's this 6-foot tall person here, and they're standing next to the building, and they cast a 7-foot shadow. Well, what happens here is I have 2 similar triangles. I've got the building height, which again, I don't know, but I do know that the base of it is 50 feet, and I've got the person. They're 6 feet tall. They cast a 7-foot shadow. And now I could write a proportion to solve this. I could compare the height of the building to the shadow. So n to 50 feet is equivalent to 6 feet over 7 feet. So again, I'm comparing the height to the shadow length. 7n is equal to 300. I want to divide both sides by 7, and I find out that n is going to be equal to roughly 42, and I'm just going to round it here, 0.86 feet. All right, here's one for you to try on your own. I've got these 2 rectangles here, and I know that they are similar to each other, but I want to figure out what is the length of W here. It might help if you thought about rotating this around so that the shapes are looking the same. So now what I need to do is I need to set up my proportion. I'm going to compare the top to the left. So 18 to 24. And then that means on the other side, I better compare the top, which is W, to the left, which is 16. Now, if you thought about it, you could have done this, right? If you didn't want to multiply 18 times 16 and then divide by 24, you could have noticed that, hey, 18/24, that is a fraction that could be reduced. 18/24, I know 18/24 is just equal to 3/4. So now, when I solve this proportion, I could just solve it this way. I mean, there's a bunch of ways you could solve this. You could say, hey, 4 times 4 is 16. So I also have to multiply 3 times 4. W must be equal to 12. And in this case, it's 12 feet. But if you wanted to cross multiply, you could. 3 times 16 is 48. 4 times W is 4W. Divide both sides by 4. Guess what? You still get W is equal to 12 feet. And that's how we work with scale and similar figures.